So in this session, we will discuss questions related to topic motion graph and force. I'll discuss the doubts which you have sent related to this assignment. The first one is question 20. Question 16 is there. So in this question, an object which is having a weight W on the inclined surface, which is making angle theta. The normal contact force is R. As the theta increase, what happened to R? So how we can work out the value of the R? Basically, the weight will have two components. When we take the axis on the inclined surface, so weight is making same angle theta. So the component of the weight which is with an angle, that is W cos theta, and component of the weight which is against the angle, that is W sin theta. So basically R balances with W cos theta, so we can say R is equals to W cos theta. And what is the relation between theta and sin theta? They are directly proportional, means if we increase the value of the theta, the value of sin theta will also increase. And what is the relation between theta and cos theta? If we increase the value of the theta, the value of the cos theta will decrease. So what happened, they're asking, when we increase the angle, what happened to our weight is constant. So if we increase the value of the theta, the value of the cosine theta or cos theta will decrease. So if the value of the cos theta will decrease, the product of W and cos theta will also decrease. That's why the value of R will decrease. So what happened to R? That will decrease because R is equals to W cos theta. That's why A is the right answer for this. Is it clear, this question? Question 16, that was the first doubt. Next is question number 19, V1. So in this question, we have to complete a free body force diagram, and we have to assume that the surface of a ground is not smooth. So when we are applying a force of 45 is applied, so that what is the direction of the friction? The friction will always try to oppose the motion. So this will be the direction of the frictional force. And weight of this object will act downward. So we have to complete a free body force diagram. So there will be a frictional force and there will be a weight which is acting down. So that is W and F. Is it clear? This question 19B1. The free body force diagram for object which is dragged on the horizontal surface. Next is question 21. A car is towed by the truck using a single rope. The car is pulled at a constant speed. So when it is being pulled at a constant speed, it means the resultant force should be 0. The horizontal forces acting on the car are shown. The magnitude of force exerted by the truck on the car. So basically what happened, the truck is applying a force by using a string or a wire or a cord, and that force is known as the tension. So resulting force on the car, so the force which is exerted by the truck on the car, that is equals to the tension. And the resultant force, like T minus F, tension minus the friction, should be 0. Why it will be 0? Because the car is moving at a constant speed. But in the question, they're not asking the resultant force, they're asking the magnitude of the force exerted by the truck on the car. So what is the magnitude of the force exerted by the truck? So truck is actually, if truck is applying a 30 Newton force, and that is the tension in the restraint. The friction try to oppose the motion, so friction will be 30 as well. Resultant on the car will be 0. But the question was force exerted by the truck. So force exerted by the truck is equals to the tension. Is it clear, this question? Next is question 24b. The airplane is pulled backward, released, and moves forward. The graph is shown. On the axis, draw corresponding velocity time graph. And which graph is given to us? Acceleration time graph is given, and we have to sketch velocity time graph. So first thing, and the maximum velocity is 3 meter per second. So what we will do for a velocity time graph, keep in mind what slope represent. Slope represent acceleration. Okay. So if we divide the graph into parts, the acceleration time graph, example, this is from A to B. So A to B, the values will be there because you have to calculate the value as well, but I'm not going in that value part. First thing, I'm predicting, sketching a shape, and then I will work out the value for the velocity. So from A to B, it is at a time from 0 to 1.6 second. What happened? Acceleration is constant because horizontal line acceleration is constant. So from A to B, if acceleration is constant, so what I should show? I should draw a line with a constant slope. So we should draw a line because the acceleration is a constant. So we should draw a line with a constant slope from 0 to 1.6 second. And what about the value of this speed or the velocity basically? As they mentioned, the maximum value is 3 in the B1, A1. So maximum value will be 3. And it is a positive. So acceleration is positive from 0 to 1.6 second, and it is constant. So we have to draw a line from 0 to 1.6 second, which is constant slope. So 0 to 1.6 second, we'll draw a line with a constant slope. Is it clear, the first part? Then the second part, acceleration is 0. So this was part A, B, and then because it is at the same time interval, so it will be B to C. So what happened from B to C? It is from time 1.6 to 3. So 1.6 to 3, acceleration is 0. If acceleration is 0, slope should be 0. So slope 0 means we will have a horizontal line. So originally it was a straight line till 1.6 second with a maximum 3, and then from 1.6 to 3 second it will be a horizontal line, means the slope is 0, acceleration is 0, and object is moving at a constant speed. Then the last part, it is a negative acceleration. What is the meaning of negative acceleration? The negative acceleration is called deceleration. So object will slow down from 3 second to minus from 3 second to 7 second, the object slow down. So here if we divide, like this was A, B, then we were having B, C, and this is from C to D. So what happened from C to D? The slope should be, because it's a constant deceleration, So slope should be constant because acceleration or deceleration is constant in the horizontal line, but it will be a negative value. So we have to draw a slope constant, a constant deceleration. So how we represent a constant deceleration? So first it was constant acceleration, then it was no acceleration, and then from 3 second to 7 second it has a constant deceleration. Because it's a constant deceleration, that's why it is a straight line. If it was a non-uniform deceleration, then it will be a curve. Is it clear? Question 24 part B. The next one is 31 A2 and BC. So basically 31. What is the maximum velocity? Show that the maximum velocity. So how to work out the maximum velocity? We have the acceleration, and they mention that the airplane is pulled back and it is released. So initially it will be at rest. When something is released, so initially it will be at rest. So we have the formula A is equals to V minus U over T. A is the acceleration, which is 2 from the graph. V is the final speed, which we don't know. Initially start from rest. And the time, how much time it took? 1.6. So this 1.6 is multiplied. So it will be 3.2. The final speed will be 3.2 meter per second. Next is question 31, A2 and BC. 31 to this 28. Okay, this question. No, this one. So in question 31, many handheld devices such as smartphones and tablets, computers containing acceleratometer. Basically, this allowed to change the orientation of the device to be tracked. The student model a simple acceleratometer by attaching a small mass of a string, as you can see. When the cars start to move, the string is seen, it changes the position. Complete a free body force diagram. So what is a free body force diagram? The weight will act downward. We will draw on that, and there will be a tension in the string. So we as because what happened, the weight which is perpendicular always downward to the surface, and the force which is applied by a string, that is known as the tension in a string, that we represent by T. So the free body force diagram, this one will be T, another one will be W. Draw a vector diagram to show that the resultant force on a mass is produced. What is the meaning of resultant force? Basically, if there is no resultant force, if I say I have two forces acting on the object, and if I say I want to show that the resultant is 0, so if I want to show, I will add the first vector to the second vector, means I will draw the first vector, then from a head of the first vector I will draw the second vector. If I return back to the same starting point, it means the resultant will be 0. But if I'm not able to return back to the same starting point, so there will be a resultant. So we have to draw a vector diagram to show that there is a resultant force is produced. So how we can show that? So already we drew the arrows. There was a tension. So there was a tension in the string and the weight is acting. So how to show that there is a resultant? So if we add tension, like any one of the vector you can draw first. So example, first I drew tension and then I will draw the weight. So my starting and ending points are not same. So if starting and ending points are not same, it means there will be a resultant. So tension is there, weight is acting downward. So it means there will be a resultant. And how to get that resultant? From tail of the first. If I join the tail of the first to the head of the last, that will be resulting. So we have to show that the starting and ending points won't be same. That's why there will be a resultant force acting on this system. Is it clear? Then when this string is at an angle of 7 degrees to the vertical, show that the acceleration is about 1. So this string is making 7 degrees to vertical. The tension is T and the weight is acting downward. So this T will have the two components. The one which is with an angle, that will be T cos theta. And there will be against the angle, that will be T sin theta. So basically T sin theta is responsible for the acceleration and T cos theta is balances with the weight. So what are the values given to us? We have only the angle is given. The mass is not given. So how to work out the acceleration? So when we write the equation, we can say because the weight is downward and T cos theta is upward. So W is equals to T cos theta. Weight is downward and T cos theta is upward. And theta, that is angle is 7. So I can say W is equals to T cos 7. And what about T sin 7? Because that is responsible for the acceleration. Is it accelerating? So we can say that T sin 7 is equals to MA. Because there is a resultant force on the horizontal in x direction. So there is the resultant force is not 0, but the first case the resultant force is 0. Vertically there is no acceleration, the two forces are balanced. So I can even write W minus T cos 7 is equals to 0. Or I can also say that W is equals to T cos 7. So we have the two equations, the simultaneous equation, we just have to solve. So if I use the first equation, W is equals to T cos 7, so I can find the value of the T, that T is equals to W divided by cos 7. If I substitute this value in equation 2, which is T sin 7 is equals to MA. What is the value of the T? T is equals to W divided by cos 7 multiplied by sin 7 is equals to MA. What is sin 7 over cos 7? Sin theta over cos theta. In a trigonometry, you have studied that tan theta is equals to sin theta over cos theta. So what is, even I can substitute the number, but that does not make difference to the final answer. If you find this method difficult, like sin theta over cos theta is 10, you can also use the value of sin 7 degrees and cos 7 degrees, so it will be same. It won't make a difference. Now what about W? W is equals to mg, so we can write mg sin 7 over divided by cos 7 is equals to ma. So m will cancel with m, so we can say g is equals to sin 7 over cos 7. So G is the gravity, you have to take as 9.81. So we have the gravity, we can use scientific calculator to work out the value of sine 7 and cosine 7. Using that, we will show the acceleration of this object. Is it clear, this question? To everyone? Because of vertical, there is no resultant force. As you can see in the question, this is a tension. The weight is acting downward. They mention that it is making 7 degrees to vertical. So if it is making 7 degrees to vertical, it will have two components. One of the component which is with an angle that is equals to t cos 7. And another component against the angle will be t sine 7. So this is t cos 7 and this one is t sine 7. And this object is accelerating in this direction. So it means the horizontal axis on x dimension or x direction, it is accelerating. On the y direction, there is no acceleration. Vertically, there is no acceleration, that is 0. So if acceleration is 0, when we take the vertical components, t cos 7 is acting up and w is acting down. So we can say t cos 7 minus w is equals to 0, or we can say that t cos 7 is equals to w. And about the horizontal, because it is accelerating and t sine 7 is responsible for its acceleration, so we can say t sine 7 is equals to ma. Why? Because horizontal there is acceleration. Acceleration is not 0. Vertical there is no acceleration, so resultant force is 0 or acceleration is 0. So we have two equations. This is equation 1 and equation 2. You can just use a simultaneous equation and work out the value for A. Is it clear now? Next is question 31 part B. Look, sketch the position of the mass when the car is moving in the same direction at a constant velocity. Constant velocity means there should be no resultant force on x-axis or y-axis because it is moving. So if there is no resultant force, then it should be at its mean position, because if it is not at its mean position, there will be a resultant force. Then undergo much greater acceleration. If there is greater acceleration, there will be a greater resultant force. So this angle will be more than 7. But if object is moving towards right, why this pendulum is moving towards left or accelerometer is moving towards left? Because of its inertia. Inertia is a property of an object to resist the change in state. So if, for example, if a car is stationary and you are inside the car, if you press the accelerator, which direction you tend to move, you tend to lean backward or you tend to move backward because of your inertia. So what will happen if the car is having greater acceleration? So this will try to resist the change in state and the pendulum or the accelerometer will be opposite or backward direction. Same way, what happened for if you are inside a bus or a car and suddenly a driver applies the brake, so which direction you tend to move? You tend to move forward or lean forward. So if it is decelerating or slow down, so because of your inertia you tend to move. That's why you will move forward. That's why the position of the accelerometer or pendulum will be forward. Is it clear? The three examples. Why the string would not become horizontal, however great the acceleration? Why the string cannot be horizontal? Why it cannot be like this? It cannot be the string, even greater the acceleration cannot be horizontal. It will always, the angle will increase, but it never be horizontal. What is the reason for that? Look, as the tension is there in a string, so this tension is having two components. One is with an angle t cos theta, another one is against the angle t sin theta, and weight of this object is acting downward. So basically weight is balanced with t cos theta. So if it is exactly horizontal, then weight cannot be balanced, because there is always a weight, vertical force, weight is there. So weight is there, there must be a vertical force from the string so that it can balance with the weight. In case if the string is exactly horizontal, so there will be no component of the tension to balance the weight. That's why it is never, or it could never happen. Is it clear? Because the weight is there for the accelerometer, so we always need a vertical component of a tension. And how we can have a vertical component of a tension? When it is making certain angle. If it is not making any angle, if the angle is zero, it means there is no vertical component to balance with the weight, so which is practically wrong. Because if weight is not balanced by any force, then there should be a downward acceleration. Is it clear? Is it clear, this part? Then suggests why many devices contain three accelerometer, all are right angle. So because the object can accelerate in three dimension, it can accelerate in x-axis, it can accelerate in x-axis, y-axis, or z-axis. That's why there are three accelerometer which are all perpendicular to each other. Question 29. A trolley rolls down a slope and it moves through a vertical height edge while rolling down a distance s. The maximum possible speed. Basically what happened? The potential energy here converted into kinetic energy. If there is no loss, we can say the potential energy will be equal to kinetic. Potential energy is mgh, kinetic energy is half mv square, or 1 by 2 mv square. M will cancel with m, so we can say gh is equals to half v square. 2 is divided, other side it will be multiplied. So we can say 2gh is equals to v square, and we'll take a root, under root. So it will be under root 2gh is equals to v. So under root 2gh is equals to v. That's why for 29, D will be the right answer. Is it clear? Then next question is 32B4. 32B4. complete velocity time graph to show motion of the lift, and use your graph, find the distance traveled, so that we'll use area under the graph. How we can represent the motion here? It, first, for 2 seconds it was having a constant acceleration, then from 2 sec for 3 seconds it does not have any acceleration, and what could be the maximum speed for this part if acceleration is 0.2? So we have the formula: A is equals to V minus U over T. A is the acceleration, which is 0.4, V is the velocity, final, U is initial, and time interval is 2. So 2 will be multiplied, the maximum speed here will be 0.8 meter per second. So for first 2 seconds, we have to show a maximum speed of 0.8 second. So this is 0.8. Then it travel from for 3 seconds, means from 2 second to 5 second. It does not have any acceleration, so horizontal line. And for the last part, for 2 seconds, it is decelerating. So same deceleration is there. So we'll have a same line. So this is how we sketch a velocity time graph for an object. So this was 32B4. Next is 34B2. And 34B2. Okay. So in this question, write an expression for the time in terms of t for a ball rolled out down a distance s by 2 from the top of the plane. So what happened in this question? During investigation, the 17th century, the physicist Galileo carried out series of experiments investigating how the gravity affects the acceleration. So there was no accurate method to measure a short time. So what Galileo did, he used an object on a smooth inclined plane to increase the time taken for object. So what he did, smooth inclined plane to increase the time taken for object's motion. An object is released from a rest and it slide down distance s on a smooth inclined surface as shown in diagram 1. This will take longer than releasing an object from rest and allowing it to fall freely through a same distance s. So this will take longer time compared to object falling freely, because on inclined surface always remember that acceleration is equals to g sine theta, whereas free fall object without air resistance, acceleration is due to gravity. That's why the time interval won't be same. So we have to write an expression for time taken in terms of t for a ball to roll down distance s by 2 from top of the plane. And as you can see, the Galileo released a metal ball from rest so that it can roll down a smooth incline, and the time t taken for a roller distance as was measured. He then repeat the experiment each time, recording a time to travel different fractions of the distance. So we have to just mention how much time it will take to roll a distance s by 2. So whenever object is falling, the acceleration is not constant. Like object is moving on the inclined surface, acceleration is not constant, or a is equals to g sine theta. So you have the formula S is equals to ut plus half at square. When object is rolled down, initially it will have zero acceleration, its initial speed is zero. So we can say S is equals to half at square. Now what we have to do, if the distance is S by 2, so if the distance is S by 2, when I write the same expression, because the initial velocity is 0, so it will be S by 2 is equals to initial velocity 0. So it will be half A, because this is the time to fall the half distance. So I am saying that's at a T dash square. T is the time to move on the inclined surface. T is the total time to move on the inclined surface. Okay, but we want the time to cover half of the distance S by 2, so we can say that is T dash. So we can say that T dash is equals to half A, or S by 2 is equals to half A T dash square. Now we'll solve this. So when we try to solve, we'll compare the two values from each other. Like here we'll compare. This is for the total and this is for the half. So when we try to compare, like if this 2 is divided, other side will be multiplied. So it will be, this 2 will cancel with 2. So it will be S is equals to A and T dash square. So when we compare equation 1 with equation 2, so we can say half AT square is equals to T dash square, or AT dash square. A will cancel with A. So we can say half T square is equals to T dash square. T dash means the time to complete the half distance. But we need this T dash, so we'll take a square root. So under root half T square is equals to under root T dash square. So what will be the value for T dash? T dash is equals to T by under root 2. Is it clear, this question? It's of only 1 mark. I use long method to explain the idea, but this simply what we did, because this is the equation which we'll use for full distance. So this will be the equation we will use for half distance. Is it clear, discussion? So to move full distance, the time was t. To move half distance, the time is t dash. Then we compare the two equations and we'll get that time to move half distance is the total time divided by under root 2. So this was exercise related to topic motion and graphs.